All right, you guys, this is another problem I want to go over. This again will just kind of help you out in that worksheet 3. It's one of the worksheets that I posted up on the channel that says Unit 5 Applications of Newton's Laws. So again, we're just dealing with problems with angles. So another common type problem. You guys have seen that guy who's pulling the box along the way. You know, we've had that problem in Unit 4, one of those worksheets, or on the test. I don't remember exactly where it was, but it'd be a similar problem to where, you know, let's say you have a flat surface this time. And the last problem I did, I had a slanted surface, I had an incline. But this time we're gonna have a flat surface, and we have some object, whatever it happens to be. And this time, maybe I increase the mass. You know, maybe it's a bigger, heavier object, and it's say 15 kilograms. And we're gonna apply a force to it. So we're gonna try to drag this object along the floor. So if we apply a force this way, you know, let's say we apply a force, whatever this applied force is, I don't know, maybe we apply a force of 50 newtons, something like that. So if we apply a force of 50 newtons, then we just want to figure out the acceleration again. Let's say maybe we have, let's say we have something like this too. Maybe we have a frictional force this time. On the last problem, we didn't have a frictional force. So this time, maybe we have a frictional force that's going to act against it. So maybe that's supposed to be an FF. I don't know what happened there. So FF equals, I don't know, let's just make it 10 newtons. So we're pulling this way 50 newtons. We have a frictional force acting against it that happens to be 10 newtons. And we have, of course, we're going to draw a free body diagram. We have a normal force or gravitational force. And then we just want to figure out the acceleration. And in this problem, I'm going to throw an extra piece on there. I'm going to try to figure out some sort of a kinematic problem. Like maybe I want to say, how long does it take to travel 10 meters? So I could say, I could actually write that question. So now we want to solve that. Of course, we can't solve that without figuring out the acceleration. We can't figure out the acceleration without applying Newton's second law. We can't apply Newton's second law without drawing a free body diagram. So what I'm going to do is I'm going to start my problem just like I start every other problem. I'm going to start by drawing a free body diagram. You guys should probably be used to that by now. You know that's where we're starting. I think where I'm going to draw that, I'm going to actually move up over here. I'm going to switch seats real quick without trying to trip over my cat that's biting at my feet. But I'm going to come over here and I'm going to draw my free body diagram. So in this case, I'm going to do the same thing that I always do, start with my FG. So my FG is going to go straight down, and that is going to end up being 15 kilograms again times the acceleration due to gravity, which is going to give me a 150 Newton force of gravity. I'm going to have my normal force, and I'm going to draw it a little bit shorter. Hopefully you guys remember this, because we have to recognize that our normal force in this case is not 150, because we have this upward pull right here, which means that we're going to end up having a y component of this, which is going to come off of my Fn. So those two forces together are going to end up having to equal 150. So we know our force normal is going to be less than 150. How much less? Well, it probably doesn't really matter for this problem. Again, if we wanted to figure it out, we could. So in this case, we're going to have our force this way, which is our applied force. I called it an FA. You could have called it FP, FT if this is a rope. Who knows? Whatever. It doesn't matter that much. I happen to call it an FA. I don't know why, just because it sounded good at the time. So force applied equals 50 newtons. I didn't specify an angle here. Let's just go ahead and say that it's a 20-degree angle this time. So 20 degrees. This marker's messing up on me. There we go. A 20-degree angle. So now when I draw this in, I'm going to have an angle that's going to be 20 degrees right here. So when I draw my components, this angle is a lot easier to see than the last problem. So this is going to be my FAX. This is going to be my FAY, which doesn't really matter in this case. But here, this is going to be 20 degrees. So I'm going to have to figure out my FAXs now. And then the other thing that I have is with this particular problem, I threw friction in here. So I'm going to draw my arrow back this way, and I'm going to just throw a force of friction. And I said I said 10 newtons because that's easy to subtract. So 10 newtons. And now I'm good to go. I can solve my problem. So I need to figure out, I have to figure out my FAX is, because I want to figure out what my net force is. So if I come back over here and I say, okay, sum of the forces equals MA, my sum of the forces is going to be my FAX right here, because these are all gone. I don't have to worry about my Y components because those are all gone. The box isn't going to accelerate up or down. So I'm worried about this force right here and this force right here. So my sum of the forces is going to be my FF plus my FAX. But I have to figure out my FAX. So I know that I can just plug in, just using trig. I can say that this is going to be my cosine side. So I can just come off to the side and say, okay, well, cos 20 equals my adjacent, which is my FAX, over 50 newtons. In this case, I have to do 50 cosine 20. That one I can't do in my head, I apologize. So I grab my calculator, I again make sure that it is in degrees, and it is. So I'm just going to go through 50 cos 20, and I end up with a force of 47. So 47 newtons is going to be my FAX. So FAX equals 47 newtons. I rounded that up from like 46.98 or something like that, so that's fine. So now if I have my FAX being 47 newtons, that's right there. So now I can look at my sum of the forces, which is going to be 47 newtons, and I'm going to add that to a negative 10 because it's the opposite direction. And then my mass is going to be 15 kilograms. And then I want to solve for my acceleration. I wish I would have chose a better number so it would be nice and easy to divide, but instead I end up with 47 plus a negative 10, which can be 37, and then I just divide my 37 by 15, so I'm just basically doing my algebra, which is going to be 2 and some change, like 2.5 roughly, so 37 divided by 15 to be exact would be 2.47. I could have just said 2.5, but that's okay. 2.47 sounds all right. So 2.47 meters per second squared. So now I have my acceleration. So again, this is all stuff that we've done. We've done angles in the last unit. You guys could look back at some of your old worksheets and figure out how problems, look at problems that we had with angles, almost stuff very similar to this. The only difference now is that we have forces that are not balancing, which means that we now can use Newton's second law to solve for an acceleration. It's just F equals ma. Watch your signs and then just do the math. So in this case, we have an acceleration of 2.47 meters per second. Okay, so now the question here was how long does it take to travel 10 meters though? So now I'm going to come over here now, switch my seat, kick the cats out of the way, and I know he's like biting at my feet.
They're both.
Okay, all right. So I'm going to figure out the things that I have now. So I'm looking for time because it's asking how long. So I'm looking for a t. So I'm going to put t equals question mark. I have a delta x because it's telling me that I'm traveling 10 meters. I'm going to make the assumption that it started from rest. I didn't specifically say that in the problem, but I'm going to use that as an assumption and just say v naught equals 0. And then I have an acceleration that I just solved for over there of 2.47 meters per second squared. At this point, I have enough information I can solve my problem. I don't know what my final velocity is. I could solve that if I wanted to, but that's fine. I'm not going to do that right now. I'm just going to answer this question. So if I go through my formula sheet, speaking of, if you guys need another formula sheet, I'll just post another one up on somewhere in the, probably in the same place I'm posting things under the channel and the files. So you guys can have a formula sheet at all times if you need it. So if I do this, I end up with a formula that's delta x equals 1/2 at squared plus v naught t. Now my initial velocity I stated was 0. I didn't state it up here. I probably should have said that at the beginning of the problem, but I'm going to make the assumption that the initial velocity was 0. If it wasn't, then I just plug in whatever the initial velocity was there, and it would have changed my answer. But I'm going to assume that it's 0, which makes this whole term 0 because 0 times anything is going to be 0, so that's gone. So now I just go through 10 meters equals 1/2. My acceleration is 2.47 meters per second squared times t, and that's squared. And then I just go through and I grab my calculator again and calculate that, and I can figure out my time. In that case, I have 20 divided by 2.47. I've got to root that, and I have 2.8 seconds. Rounded, of course. Okay, so again, that's just another problem. Adding an extra piece there because we have the kinematic portion to it. But again, this is all stuff that you guys have done before. So we just go through, you draw the picture, you draw your free body diagram, you identify where you have the imbalance of forces, and once we realize that these aren't balanced, there's going to be acceleration. You just figure out the values, plug it into sum of the forces equals mass times acceleration. Here's my sum of the forces, and you have your A. Once you have your A, you can solve all kinds of different things. In this particular case, like I said, we're solving for time. So we're gonna just figure out our unknowns, write out our unknowns like I've shown you guys to do before, and now we just plug into a formula, and there you go. 2.8 seconds, we're good to go. All right, have a good day.